Good morning, everybody. I'm Dr. Shanti Amjad, Associate Professor, Department of Physics, RMK Engineering College. In this video, I would like to share about semiconducting lasers, both homojunction and heterojunction laser. Semiconductors are also used to generate laser beam. It is the most compact laser. When a forward bias is applied to a PN junction of a semiconductor, holes are injected from P region into N region and electrons from N region to P region. The electrons and holes recombine and release of energy takes place near the junction region. Semiconducting lasers are classified into homojunction laser and heterojunction laser. In a homojunction laser, both the P region and N region are made up of the same material. So it is formed in a single crystalline material. An example is gallium arsenide. In heterojunction laser, both the P region and N region are made up of different materials. Example is a heterojunction laser is formed between gallium arsenide and gallium aluminum arsenide. Homojunction laser. It is a specially fabricated PN junction device which emits coherent light under forward bias condition. Principle. The electron in the conduction band combines with hole in the valence band and produces energy in the form of light. This photon induces another electron from conduction band to move to the valence band and stimulate the emission of coherent photons. Construction of a homojunction laser. A narrow p-n junction made from single crystalline gallium arsenide is the active medium. The ends of the junction diode are well polished and made parallel to each other. It acts as an optical resonator. As the refractive index of gallium arsenide is high, external mirrors are not needed. The remaining two phases are roughened to eliminate lacing action in these directions. The p-n junction is forward biased through electrons. Working. Population inversion is achieved by heavily doped P and N regions. Before biasing, the Fermi level lies within valence band of the P region and within the conduction band in the N region. When the junction is forward biased with the voltage nearly equal to the band gap voltage, electrons are injected from N region and holes are injected from P region, and they get accumulated on either side of the p-n junction, and hence an active region is developed. When a radiation having frequency nu is incident at this region, recombination of an electron and hole is started, and hence a photon of energy E is equal to h nu is released. This photon induces the injected charge carriers to emit photons. These photons are reflected back and forth at the junction, and hence more recombination process takes place. As a result, large numbers of photons are produced due to increase in the rate of recombination process. The emitted photons have the same phase and frequency of the inducing photon. Hence, an intense coherent beam of laser emerges out from the partially reflecting phase of the p-n junction. Wavelength of the emitted radiation depends on the band gap of gallium arsenide semiconductor and the concentration of donor and acceptor atoms. The wavelength of the emitted laser is in the near infrared region. Energy gap Eg is equal to h nu, which is equal to hc by lambda, and energy gap of gallium arsenide is 1.44 electron volt. Hence, the wavelength of the emitted laser light lambda is equal to hc by Eg, which is equal to 8626 Armstrong unit. This is the energy level diagram. The first one shows before biasing, where the Fermi level on p region is in the valence band and the Fermi level on the n region is in the conduction band. Now, when the biasing is applied, we have the band is bent and the charge carriers cross over the junction and recombination takes place, produce laser light. Characteristics of a homojunction laser. So the type is homojunction, active medium is the PN junction, active center is the recombination of electrons and holes, pumping method is direct conversion method, optical resonator is a polished PN junction, the output power is 1 milliwatt, nature of output it can be pulsed or continuous, and the output wavelength is between 8400 Armstrong unit to 8600 Armstrong unit. Advantages: it is low cost, it is easy to manufacture the diode, it has high efficiency, powerful and coherent than LED. It's a very simple and compact arrangement, less power requirement for operation, and the output can be easily modulated by controlling the junction current. Disadvantages: it has a large threshold current density and pulsed mode output only, and the beam has large divergence, poor coherence and stability, poor electromagnetic field confinement, and low power output. Applications: it is used in fiber optic communication. Laser diodes are more powerful and coherent than LED. It can be used in laser printers. It can be used in recording and reading data in CDs and DVDs. It is used in barcode reading. It can be used as a painkiller and also heals wounds due to infrared radiation. Next, let us see heterojunction laser. The electron in the conduction band combines with a hole in the valence band and produces energy in the form of light. This photon induces another electron from conduction band to move to the valence band and stimulate the emission of coherent photons. Construction: there are 5 layers in the heterojunction semiconducting laser. A layer of narrow bandgap p-type gallium arsenide, which is the third layer, is sandwiched between layers of p-type gallium arsenide second layer and n-type gallium aluminum arsenide fourth layer, which have a wider energy gap and a lower refractive index than gallium arsenide. The active region is gallium arsenide, where the laser emission takes place. The first layer is the contact layer, which is made up of a p-type of gallium arsenide, and the fifth layer is the substrate, which is made up of n-type gallium arsenide. Forward biasing is given using the upper and lower electrodes. Working: the principle of working of heterojunction laser is the same as that of homojunction laser. When the diode is suitably forward biased, electrons from the fourth layer and holes from the second layer are injected into the third layer, thereby creating an active region. Now, population inversion is achieved. Some of the injected charge carriers recombine and produce spontaneously emitted photons. These photons stimulate the injected charge carriers to emit photons. The emitted photons are subjected to reflect back and forth at the junction, and hence coherent photon density is amplified inside the active medium. Finally, an intense coherent beam of laser emerges out from the PN junction of active region. The band gap difference prevents the diffusion of injected charge carriers. Thus, the active region is very narrow. The change in refractive index of the layers is responsible for the confinement of injected charge carriers in the active region, that is between the layers 3 and 4. Since the active region is few microns wide, the threshold current density is drastically reduced. In this type of laser, high power output, narrow spectral width, higher efficiency, and high coherence can be achieved. It is highly stable and has longer life. The wavelength emitted is 8000 Armstrong unit. Here, the energy gap is 1.55 electron volt, and hence the wavelength of the laser emitted is 8014 Armstrong unit. This is the energy level diagram. So we have the third layer, that is the active region, and on either side you have second layer and the fourth layer, which is made up of gallium aluminum arsenide, and the active region is made up of gallium arsenide. Characteristics: here the type is heterojunction semiconducting laser. Active medium is PN junction with various materials. Active center is the recombination of electrons and holes. Pumping method is direct conversion. Optical resonator, it's a polished PN junction, and output power is 10 milliwatt, and nature of output is continuous wave. The wavelength of the output is 8014 Armstrong. Advantages: very narrow beam with high coherence and monochromaticity is achieved. Continuous wave operation is possible. Carrier and optical confinement can be achieved simultaneously. High output power can be achieved even with low operating current. Threshold current density is very low at room temperature. These are highly stable with longer life. Disadvantages: cost is higher than homojunction laser. Growing different layers of PN junction is difficult. Applications: it is used as optical source in fiber optic communication. It is used in CD reading or writing data and in laser printers. It is also used in holography. Thank you.